We're going to be making this awesome thing today. Stay tuned. Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. And of course, it is an exciting day for me because I do love these Velleman kits. They really bring me back to my childhood of being in a Maplin or a Tandy, and that's Radio Shack for you guys in the USA, and dreaming of being able to buy one of these and own one of these. Well, my father sent me this to build for him. He needs a basic attenuator, and this is just that. It connects to your hi-fi system as far as I can tell, and you have a level knob on it, and you have some input channels and output channels on it, and you can attenuate your signal. It's just like a volume control, but the difference with this is it comes with a remote control, and that's effectively it. You're building your own little piece of hi-fi equipment. And it gives you two stereo line level RCA inputs, one stereo RCA output. So two inputs and one output. Interesting. So I wonder if it must be doing some mixing as well. Motor controlled volume control, which is really cool. RF remote for all the functions. Well, there's only two buttons, so I'm guessing volume up, volume down. The remote does not need to see the receiver. Yes, it's not an infrared remote, it's a wireless remote, which is really cool. That's like what you get on Amazon Fire Sticks and stuff these days and modern day tellies. Self-learning code, range up to 15 meters, sounds probably plenty for most people's lounges. Manual operation possible, yeah, just twiddle knob. Gold-plated RCA connectors, relay controlled input selection, and totally passive. Wow, it does have input selection. What? Anyway, oh, that's cool. Yeah, that's why you can see here on the front that it does have a picture of the channels, and there is a tack switch underneath the channels. So this is, again, say, exciting treat. I never had a full kit. I would have just had the PCB of components. So this is something else. Now that is a proper plastic enclosure. Ooh. That is fancy. I wonder if they use this as a project box for other projects. I'm sure they must do. That's too nice just for this thing, but crikey, that's good. And we'll put the fairly comprehensive feeling packets of components aside. And the remote control is a kit. So I've used their remote control receivers and transmitters before, but they're always pre-built, so it's an actual kit version. I wonder if it's the same. Look at that cutie. A motorized volume control. I've never really seen one up close, and I'm sure this is kind of a cheapish take on the thing, but that's absolutely fine. You can understand how it all works. I think I would be reasonably encouraged to look at how to do this in the future. And you can see here I'm twisting the pot. It's got a clutch. You can see in there the inner race is just slipping on the clutch. That's so cool. So that's why also when you see these motorized volume controls, you turn them by hand. You know how they feel really good? It's because they're dampened by the clutch. It's not that you're necessarily turning the motor around. Ooh, and I'm sure some of these are belt drive. Anyway, doesn't matter. We've got something to play with. That's the main thing. And that's the bottom. Not quite as fancy a finish, but same plastic. And that's a PCB and a half. Big, chunky, what was that, 2 mil? 1.6. Nice PCB, very clearly laid out through hole. And look at the top though, isn't that wonderful? It's telling you how to operate the learn modes. It's giving you the instructions and all of that. Reception indicator. Push transmitter, adjust L1 for max brightness using a plastic trim tool. Brilliant. And what's that? So that's your power supply stage. That's your input selection stage. So those are your RCA inputs and your relay that was switching between the two. So I'm guessing it's just switching between one or the other like that. So one's always in circuit. Probably defaults to a particular channel, but I'm sure it remembers that when you turn it on, it'll just flick that relay if it needs to. There's the motor control circuitry, and that'll be your transistors here for your H bridge. And I'm guessing this is going to be the remote control circuitry here, because say it's not a pre-made one, it's being supplied as a kit, and these remote controls have an IC or two ICs here that are controlling I think the rolling codes or whatever it's using, yeah, the various code things, it's probably doubling up the IC, the microcontroller to that. It's actually doing these controls as well. Let's see if we can see anything for the relay, for example. So we've got the relays over here. I'm sure if we trace it through, we'll find that this will be a trigger coming through exactly that to that IC. In fact, it is. It's coming down here to IC1. We'll see that if there's instructions. I notice there isn't any instructions in the box, so hopefully they've got those elsewhere. And you can see two lines here coming up from that IC to here, and those will be adjusting the transistors, flicking the transistors for that H-bridge. So it's nice and simple. I'm quite excited to get started with it. So let me, well, let's just look at the last bit in the box before we get sort of settled. By getting settled, I mean probably getting some instructions off the internet. And these are the panels. They've got the plastic coatings on them. That's wonderful though, isn't it? I mean, if you make a project, the problem with projects normally is that they look pants. I mean, unless you spend a lot of time on the enclosure and the metalwork, and this is something I've done before in the past, and it involves CNC milling or laser cutting and messing around. It's more stuff than most people are prepared or tooled up to do. So when you get the plates like this ready to go, good to go, it's fantastic. And it does look a little bit scuffed. They do look a little bit marred, but I'm sure it's just the plastic coating on the front there. Great, okay. I'm going to go and research some instructions. I had to print out the manual. It took a while actually. It's at least 16 pages there, but that's fine. The original one I think is with my father because he was having a look through it and omitted to send it on. Assembly. Skipping this can lead to troubles. By the way, I did notice something here on the top again. It has obviously the difficulty level from beginner to advanced, 1 to 5, and this is a 4, but total solder points 220 plus 65. No idea what that means, solder points. I'm guessing there's possibly some sort of loyalty scheme on here. So it's telling you, oh my word, what? Axial components are taped in the correct sequence. That is the business. That is impressive. I'm going to check that out. And we have a nice color code table. Probably should have printed that one in color. What's this craziness here? GB, there you go. Find the language. Okay. I really don't like having to decode resistors for color bands, so I was going to say hopefully we won't have to, but then it's showing you all of the resistors. Wouldn't it be nice? Some of them actually just write the colors out here of what they should be. So you're going to have to go back 100, then you have to go brown, black, black. So you could go through and write them all, I suppose, if you're keen on that. But that's neat. Look at the detail on these instructions. And then I'm just flicking through because we just don't want any surprises on it. Looks so far so good. We're going to have to find our own power supply. And then we're going to have to test it. Although I'm pretty sure I don't have any of these leads, so we'll just do some sort of cursory electrical test. Right, onwards and upwards. Bum biscuits. I've just been getting my engine revved up to start soldering, and I've just read this here though. This manual only deals with the assembly and testing of the passive preamp. Please refer to the supplied RF remote control manuals for details on the assembly and configuration of the RF remote control unit. Well, I've got one that I used in a garage door project, which is a pre-made one, so maybe if we're lucky we can somehow reuse that in our tests, possibly. This might save me having to look up the instructions for that because it's just a pain. And also, hang on a minute, have they mixed up all the components? How do we know which ones are for that? Oh, I do like they have the little plastic adjuster. Tune it in. I suspect it's all just mixed in together here. Let's keep pulling this a lot apart. You've got your feet, you've got your hardware. It's nice they've got everything there you might need. In fact, look, even there. What would that be for? so much to potentially lose. Be very careful. Right, I did write down the components here. So let's see, you've got 2 jumper wires, that's correct, 2 jumper wires, and then it did have a bunch of resistors. R1, it says brown, black, black. No, let's go this way round. No. I mean, they're obviously in some order. But I don't know if they're in a construction order. They're definitely not in the order that's listed here. I was starting to get hung up on this. I was even on my Discord having a little whinge about it, but I've decided just to embrace it and just start. You know, sometimes with these things you just have to start somewhere and figure it out as you go along, because otherwise you'll just lose your mind. You know, I started counting the components, seeing if they're all there, and you know, maybe miscounting potentially, or you know, maybe they aren't all there but they have substitutions, and then worrying about all of that stuff. And it's like, well, you've got the board here, it's pretty clearly silk screened. Why not just start soldering down parts? Let's do the thing it suggests, where you're going in the order of the tape, and if we come to any issues, we'll just solve it along the way. Really, it's all standard stuff, and if we need any additional parts, we've probably got them in the floor sweepings from other projects. Let's not worry about it. I think the bit that throws me the most is that they've mixed in the hand transmitter with the main unit. So anyway, I've just put in 2 solder jumpers, you've seen that. Next one is this, looks like an inductor to me, so I think this is probably our L2. In fact, I should have looked for L2 on the board, but could it be there? That would be my guess, but I am a little bit worried about that footprint, so let's have a quick look through here. Ho hum, ho hum. And you know, there doesn't seem to be anything similar in there, so let's just shove that in. You gotta be careful sometimes, they look like a resistor but they're not. There'll be an NRIS. Pop that in there. It's a bit like an Airfix kit, this, isn't it? It's definitely more involved than the little kits we get from China normally. And I suppose the reason being, at the end of this, you're going to get something that hopefully should work well and you'd want to keep. So I guess it's a totally different market than the make a 20-minute video on YouTube about something. Okay, so that's our inductor in, and then we just go to the next one now. Interesting enough, we have a bunch of little diodes, and the first one, and you've got to be really careful reading these, we've got a 5V1, which is ZD1 apparently on our diagrams. So then we're going to have a look here. Where is our ZD1? Zener diode 1, and it will have a direction. So we have a D1 here, but that's not what we want. We want a ZD1. ZD1. When the crowd say bowl selector, there it is, right there, ZD1. It's always looking in front of me. I bet you guys at home spotted it ages ago. So when you're doing that, you've got a little line on your diode. So read the writing on the diode, make sure it says 5 volts or whatever the marking should be. Then cross-check that with the component number, and then make sure that's where you fit it. And we're going to do that. And don't worry, I don't think we're going to go through every single one on the video, because that would be exceptionally boring. However, sometimes I do get told off for doing that. So what we'll do, we'll try to stop. We'll try to stop the video on any critical components. And you can see I'm just cutting the leads, by the way, as I go along. I'm pacing myself. Normally I just do it all at the end and rush through it, but there's really no point on this board. You're going to be here a while if you start this project. And then the next diode here in the list, and I'm twisting it round, it says 4.3 volts, and you won't be able to see that on camera. And then I look in the reference here and it says 4.3 volts. Oh, hang on. That's ZD1, so I actually made a mistake. So I'm going to swap that one out and swap it with this one. Bum. Fortunately though, it's only moving it from here to here. There, that's fixed up now, but you get me. What was the order for that? They say put these things in order and it's mixed around. It's crazy. Anyway, I'm going to bash through and get a bunch more stuff on the board. So far, so good. All of the resistors are definitely coming out in the right order, and I'm checking them as I go along. So for example, this is R10, and it should be brown, grey, orange, and then I've written on my little list just off camera those colours, and it's correct. And then I'm just popping them down in the little footprints, and I'm not pushing them through, I'm just poking them so they're hovering. And then we've got R9, and then that way I'll do them all in bulk. We're getting to the point there where I think I'm going to solder them because we've done this little section. So here's R9. I suppose depending on how much you trust the kit, you could just run along and do them all like this. It's super fast. I'll probably say I'm maybe 10 minutes into it, and if you look from the strip here, I'm about halfway through. So yeah, great, good job on that. Knowing which end to start would have been useful. I have to admit that's probably what caused the most issue for me. But now we know. It's not too bad. And then once the legs are through, sometimes I'll just only heat one leg and then make sure they're all straight and go again, or other times, like now, I'm just going to heat them all. It's not too much of a problem to straighten out if one's not sitting all the way home. You can see you can just whip through them pretty quickly. Does not take long at all. So far, so good. It's at some point we're going to have to start hunting out some of the other components that aren't axial, but we'll worry about those when we come to them. As far as this board goes, we've come to the end of our tape, so I'm going to assume that what remains is for the remote controlled unit, so I'll just pop that safely over the way. And we're going to start now on the little random assortment components. So they're the non-axial things like electrolytic capacitors, relays, connectors. And the first thing the instructions telling us here is the IC socket. So we definitely have an IC socket. We're going to pop that down. That's nice and easy. And of course, where you've got an IC, you'll normally have a capacitor next to it on the power lines, and just above it you can see that there. I'm just studying this because actually, interestingly, it's saying you've got IC1. I think it's implying that you want to put the socket down and the actual IC itself. So oh yeah, there it is. IC2. No, it wasn't. It wasn't implying you need to put the IC down. It was implying you need to put both sockets. So now these are a bit more challenging, especially if you don't have a bit of foam, which I don't. So what I am going to do is I'm going to put some pressure. So it's flipped over on its back. I'm holding the board just with a little bit of pressure, and I'm just going to load the soldering iron tip here and just touch it off one corner, and then do the same for one of the other ones. And then those tacks will keep it in place to allow me to turn it upside down properly. Just push some additional pressure on there while I solder them up. But again, no particular issues with these parts. These are all really easy. You don't even have to trim the leads when you're done with them, so that's fine. And you can see there, look, there's a join. Away it goes. They're very easy to solder. You know, you really can't make a mistake. Just make sure that, like that, if you did accidentally bridge it, that you make sure you clear that before you're done. And this is really useful. These are transferable skills. There's no difference to soldering this and soldering any ICs in an old retro computer. It's exactly the same stuff. The only bits you'll have to learn for that, though, of course, are the removal, which can always be a bit trickier. So we've got those there, and now the instructions are calling for a whole bunch of capacitors. And before I go away and do them, you know, you'd probably be bored watching me soldering capacitors. We'll start with all of the ceramics here, and then when we get to anything else, electrolytics and whatnot, I'll show you. But they're all written, they've all got values written on them, so you want to just check as you pull them out of the instructions. Like here it has 104, and conveniently here it shows you that in the nomenclature. So just whip them out, and you know that C2 to C9 are all the same, which is pretty good. Let's fit a couple, shall we, while we're here. C2 to C9. So I'm just again studying the board, looking for it. So those are regular capacitor pictures, by the way, which are just the two little lines like that. There's no polarity, anything like that to worry about for those. The only difficulty you have is just locating them. So I'm just searching around just to get our C2 started. Oh yeah, C6, C2, there we go, C2, C3, C5, C6, and is there a C9 on there? We know they're all the same, so I'm just going to pop those in from the top, look. We could find C9 though, C2, C3, C5 and C6. Come on. C9, where are you, C9? Are you in this vicinity? I'm guessing C9 isn't in that vicinity, so we won't worry about it too much. So I'm going to be very ginger, little wiggle. You can see they've all dropped through now. That's them little blue things there. So if you're ever doing one of those board restorations like Rob Taylor's Amiga board or C64, you'll see loads of stuff like this on it, and that's how you deal with them. And what I like to do, same as the rest, just do one leg, turn it over, let's just have a little check, and it's sitting a bit proud, and then just with a little bit of pressure on one finger you can just push it through. In fact, you don't even have to turn the board over really, you might as well just do it while you're here. And then we'll just solder those remaining pads. And those two, they look like they're bridged, but they're both to ground, so that's actually okay. Give them a quick trim. And away I go. Those are all good. They're pretty easy actually. I've got a checklist here along the side as well. It was all clearly written, no problems there. So now it's time to hit some of the transistors, and let's see if those are clearly written. So we have a C547C, and I'm looking here, 547C. Yes, we do. That's good. That's what we want, some of those. 557. Yes, that's what we want. And there's going to be one more, which is a 199. So let's see if there's something loose, something odd and something loose on its own somewhere in here. Ah yes, there we go. And that's the something odd, something loose, which happens to be T5. So I think I'm going to go for T5 first, just as it's elusive and exclusive. So let's zoom in a little bit, see if we can find this T5, and I'm just going to double check that as well. Actually that isn't the code for the T5. There is another one here though. Let's check that. That's the one. Got to be careful, my gosh, that must be for the transmitter. I don't like the way they mix those up. Okay, T5. So you'll notice the T5s will have this sort of roundish footprint like a D with 3 dots. So we have T1, 2, 3, 4, T6, T5 right in there. So this is the counterpart, this is the receiver one, and just got to bend the legs back a little bit. The footprint isn't quite as described by the part, so that's okay. I've just bent the legs a little bit, and you'll see we'll be able to just fit that in. A little triad there, just poke it through. Again, maybe not poke it through all the way, because I'll try to fit some more. So we'll start with the T1. So the T1 is the 457s, which are these. So T1, T2 are the same. Again, just the same process. Try to clean off any glue though. I do like to dogleg these out a bit if you can, and just get your tweezers to do that, just so that you get that triangular shape as you're popping them in. Make life a little bit easier. So T1 there, and T2 is the same. And if you're worried about juggling the board and losing track, just solder them one at a time. That's fine too. I'm just doing it to save time here, but it'll certainly cost me a lot more time if I accidentally hit the board and drop all these out. And while I'm at it, I'm going to fit that T6, which is just at the top of the shot there, because it just happens to be the same as all of these ones. And it is scorching today, absolutely scorching. I don't know if it's hot where you are, but it's certainly hot here. It's T3 and T4. Now these were the 557s. Again, just probably off camera here slightly. I'm just adjusting those. I'm going to fit them. I have to say, despite my initial reservations, that once I kind of understood what's going on with these kits, it really is an easy kit to construct, because everything is done so nicely. Their quality control must be super high to make sure they don't lose any of these parts in packing. So transistors tend to be quite fun to do, because if you poke them through, they tend to have a bit of bite, especially when they were the 3 pins in line and you're making them fit that sort of triad shaped hole. And because they're taller than the other components, you can push down and they'll really push up against you. And I suspect that's part of the reason as well why they give you this particular build order. I don't think you're going to get in trouble. So I'm just going to go through real quick. You can see there. And if you can just hit one leg and not disturb anything, you're normally just pretty much good from that point on. Keeping an eye out for bridges. It's normally okay on this board. Anywhere that it looks like you could have a potential one, it does happen to be to a ground plane and they're both next to each other, so that's not too bad. But that doesn't mean you can't make a mistake, so do it a lot slower than I do and check your work as you go along. And we'll just trim those. And looking ahead to the instructions now, we're getting right to the meat of the device. We're talking about push buttons, jack connectors. I mean, we're almost we're at all of the fancy components. I suspect that the remote control, because it's so small and dense, will probably take just as long to build. But we should be able to get this quite operational, because it does say on the instructions that you can manually drive this thing. So make sure, again, like that, where you don't have a leg that's stuck to the board with its own flux. Okay, so we're looking now for switch 1 and switch 2, which I think that's one of them. These are the 90-degree tack switches, because they're going to go out through a front panel. And they just sit in like that. Again, be kind of careful with these. So these are something that, if you need to, like me, just tack solder them in and really make sure they're sat correctly, because they've got to align with the front panel. So I'm just checking that. Yep, they're not going anywhere, they're about right. And the back legs go to the metal of the enclosure. So once you've got those back legs in, those switches are not going to go anywhere. It's a decent type of switch as well for this. I actually think this kit will last you a long time in operation. You can see I'm holding the solder a little bit longer. We're a little bit dirty there. It needed a little bit longer to activate the flux. I'm just off camera spooling myself some more. That's good. That's looking pretty good. Spooling myself some more solder. It was getting snagged up. DC jack at the back. Again, I'm pretty sure they're doing all this in order of height. And then we've got 2 power regulators, some electrolytics, looks like LEDs, a few LEDs, an inductor, the electrolytic relay and the things, and we're done. So yeah, this is exciting. And the next part is Phonos. Gosh, that, you know, soldering on Phonos, once you're there, you're on the I/O at that point. Let's check this. Again, anything that connects to the panel, and we're going to have to do the same on the Phonos. See that? Ooh, there's an ever so slight amount of play in the lateral as well, which means the left and right. So make sure that it's as centered as you're going to get. I mean, I should think that there's tolerance on those panels, but you want to try to make your part as accurate as possible. Don't rely on somebody else. Now, because these, it is the Phonos next, indeed. Yes, it does say black, red, black. I was going to say these will be color coded. So you want to make sure you use the right ones in the right place. Okay, that's looking like that. So we've got SK2, 3, 4, 5, 6, 7. So it's going SK2, black. Oh, gonna have to push it off the board. Black, red. Whoa, black. These are nice, they're snapping in too. Come on now. Come on, dear. That's looking nice. Then straighten them out as best you can, because you won't have the opportunity to once you solder them. So looking at the bottom here, you've got a middle pad and then 2 outer ones. I would suggest just go for broke here and solder all those middle legs. Oh, it's taking some heat. It's a massive pad, and you don't have to flood the lot with solder, to be honest with you. It's up to you. What I would suggest, and I'm going to zoom in so you can see what I've done here. I've filleted it. I've added a little fillet here to each one. Yeah, I'm going to make sure they're aligned, and then I'll put a bigger blob on there, and that will put that whole footprint will be locking that in, and that's going to be where that connector will get its strength. Again, more than enough, I'm sure, as is, even now. But why would they do it if they didn't want you to do that? Right, I'm just twisting it up, making sure they're all aligned. So they're all pretty straight now, because once we do the rest, they'll start to lock in. And let me move things around here. Let's zoom in a little bit on this. I might go nuts. I might go and just fill in everything while I'm there. And look at the size of these things. You're going to need to sink a lot of solder in here. So don't dilly-dally though. You don't want to overheat the plastics on this thing. If you want to, skip one. That'll give it a chance to cool down. And then you can come back and do the other side. I have to pull out a lot of solder here because it's eating it. It's really eating up the solder. Let's crack on. Nice. And then we'll just do the other side. Look, you could just feed it from one side, that's fine. My soldering iron's up at like 370 degrees. It's super hot, so it's allowing you to feed it. But if it's not working for you like that, you don't have as hot soldering iron, just dab it. So noticing here, that's an earth bond here. That's why these two are joining each other. That's okay. And then what I'm going to do is flood fill this around that connector and around that pin there. So it just goes around the back too. And that means that thing is incredibly strong now. It really will not be going anywhere at all. Could be useful if you've got kids. Put it that way. I have kids. If it takes an extra few seconds to make sure that there's a slight chance it will survive getting yanked off a table, then I would definitely spend the time doing that. We have a tuning coil to fit. So that's the thing that looks like a little twister wire with a screw in the end. God, I remember things seem to used to have loads of these back in the day. But I guess it's all digital now. Now this thing, I'm going to be a little bit more cautious when I'm soldering it. Because I really... It's a soft plastic. I can feel it's a soft plastic, so we don't want to sink too much heat into that. So I've bent over the legs ever so slightly. And I'm just going to boom like that. I think that's absolutely fine. Again, these two look like they're bridging, but they're all on the same signal. So don't worry about that. Now these things, of course, are for tuning RF circuits, and you can't use a metal screwdriver, otherwise it interferes with the whole circuit and it will go wrong. So that's why we have that extra little plastic tool in the kit. So let's get some more solder ready. And the next part we're going to do is the relay. We're almost on the final run here. We really are. Look, it's coming to the motor. You know when you get into the motorized volume control, you've got to be near the end. So relay, no problem at all. Let's just do the same trick, holding the bit of solder there because we're going to tack it. And I'm going to go alley-up. There we go. I don't know what alley-up is from. Isn't that what they used to say in circuses when they were on the trapeze? Boom. Look at that. That works pretty well, actually. If you know how much I'm allowing, about what? Just under a centimetre? That works okay, actually. That could be my top. Oh, no, it's not. It's not okay. I wasn't holding the relay right. It's poked itself through. No. Okay, so I'm just applying a bit of pressure while pushing. You can hear that the legs are snapping into place. Snapping is not the sound you normally want to associate with electronics. That's fine. And I'm just giving them a little touch. Make sure that they're nicely coated all the way around. Because it is a mechanical part after all, and it will be jiddy-juddering. So that's that there. Electrolytic capacitors. Now, electrolytics, if you've been recapping any computers, you know what they're like, and we'll have a bunch to do now. So I'm just going to sort it out. It looks like we have 5. And that actually turns out to be 5 in hand, so that's probably all of them. Just as well, really. You don't want capacitors like that in the remote control unit. So I'm just going to read them off as I go along and shove them in the right hole. So this one is 1 microfarad, which is on C18. So let's see if we can locate C18. And I drew a deep breath there because it was a C18. Now I'm sure you guys playing at home can see it already, but there it is. Remember, the long leg goes in the positive, and I will zoom in again to show you. There's C18. Finally, I've started to remember that long leg is positive, but of course on electrolytics you have that band that you can just see there in shot, which is a negative, indicating the negative side of the electricity. Can't go too far wrong really. 470 microfarads C4 again, but the long leg positive, that's good way of measuring it out. For another 470, which is a C8. And these are going to be fun. You can see how jiggly they are already. 1000 microfarads is C1. And then it's the last one here. Another 1000 microfarads in C7. So we had enough and they went in the right place. Now, C18's okay, but these are jiggly boys here. The jiggly boys, I might just bend them over a touch. Don't over bend them because it doesn't look nice when you solder that. Just bend them enough so they don't fall out. I'm not going for pretty right now, I'm just going for tack. And just hit one leg each. Again, you might have your own way of doing these things. I suspect everybody has their own way. It is the way. It is their way. I'm just going to hold it on edge. There's a lot of on edge soldering goes on in the back office here. We're living on the edge. Getting all that there, pushing through. Oh, there's some good soldering action going on here, isn't it? Nice. That's clean. I like when you feel it. It's like bang, all the way to the base. Ace of base. Get the other legs while you're there. This is so exciting. You could use this now without the remote. Just the power regulators. Are we going to be powering this bad boy up now? I think that's what we're going to be doing. I think the remote control is going to have to wait till part 2. We need a part 2 on this because I'm getting tired. So are you though. Gosh, if you've stuck with it, well done. Congrats. Hopefully you've got your own kit with you and you're building it along at home. Or you're just eager. Or you're just tired and you're just putting me on to help you go to sleep. That happens. People do that. I don't mind. That's absolutely fine. Right, so we have 2 of those gadgets. Now one of them is a 7809, yes, and the 7809 is VR1. And you can see on the board there's a dark area that denotes the side the heatsink goes on. VR02 is a 7806, and I'll double check that, 7806. And if you have a clip-on heatsink, you could clip it on at that point too. You could have a little finned clip-on heatsink. It probably will fit in that case, but how much power is this thing really going to use? I suspect those are way more than enough. I wonder why we have 2 though. You've got a 6 volt. Ow, ow, ow. That's a nasty tack there. Those are bad solders. Don't you worry. We're not done with them. Yeah, you've got 6 volt and a 9 volts there, so I wonder if the remote control circuit is using something else there. It's interesting. There is a circuit diagram actually in the back of this manual. We'll have a quick look at that. I kind of feel when I look at the components of this kit, it's a bit like they're reusing the remote control circuit, which you could buy separately. Oh, it's just as well I zoomed out. You couldn't see how shockingly badly I soldered these. Oh, and I have a bridge now, a real one, and a real one here I can't clear. So look, that's bad job. But I'm going to say that I did it on purpose to show you how to clean those out. If you can find your solder braid, which you can't. I can't find my solder braid, so I'm going to just use a solder sucker. Boom. Solder sucker works pretty good at that. That's fine. Dang, that did a good job. That did a good job. Let's just chop them out. You'll know if you got those wrong, by the way. As soon as you apply power, you're going to bang something. Something would definitely bang. Right, let's get those off the deck here. Clear your way. Get everything off the deck while you're moving. Little tap. Make sure there's nothing hanging about. Right, excellent. Now we're on the motorized potentiometer. This is where it gets real exciting here. So we've got the motorized potentiometer left, and LEDs as far as I can tell. And yep, that's it. We're there. Annoyingly, the motor needs wires to connect that to the board. So I don't see any wires in the kit. Oh, that's why you've got wire jumpers. Oh my gosh, we're going to connect it using wire jumpers. All right, fine. They did have those in the kit. Now I'm going to go for, oh my word, I'm just going to tack one of the legs of the potentiometer. That's it, one leg on the front potentiometer. I'm going to push that through. That's good actually. And then I'm going to go for the opposite corner, which is the chassis of the gearbox. I'm just going to let that cool. Another good time to feed out a bunch of solder because it's going to take a lot. That's good. Look at that. That's a nice one. Finish that off. Boom. No problems there. Now let's see how they intend you to do this with 2 bits of jumper wire. I'm going to do it with the jumper wire just because that's what the instructions say to do, but it's probably better just to use some actual wire, the right colours as well. So I'm going to turn it that way. So what my suggestion would be is to form the shapes you want first. And I'm thinking, don't worry, I'll zoom out if it's not in focus. You can see that kind of shape. Let's see how that fares through there. You can quite see that there. I mean, that's okay, that'll do. Just wedge something under the corner of this board so I can... no. I want to solder it basically now before we do anything, so that's it. Good. Because we've got 2 to do and they're going to be awkward, so let's just get 1 done. And it's wire at the end of the day. You can bend it round as you need. A little bit hot there. I keep intending to build a new camera mount, by the way, so that you can see the, instead of being overhead, immediate overhead like you're seeing now, we can get a angular, like a parallax view, but not right now. We'll do something. Do a bit of metal work. Right, so we're just going to get that bottom one. Again, same idea. But it's a little bit fiddly, so I might just use some tweezers. Of course, bend that up a bit. In their diagram, they're not showing it bent with hard angles. They're showing it very, very sweeping, very avant-garde, but you know. We're going for the hard angles here. I might have to do the old floating solder trick, the spare hand. That's done a good job there. And just bend that how we want it. Turn it over. Ooh, look how close we are now. This is really exciting. Just LEDs next. We could just power this up now, you know, without the LEDs, and it would just run, I'm sure, but I think we need to do the LEDs just to be legit. But that's how that's looking. It's okay, as long as that isn't going to short anything, which it's not. It's going to be in a box as well. No? So, LEDs. And I like that there's an LED on the volume on both sides. That means it flashes for positive and flashes for negative. Ooh, hang on. We have a lot of LEDs of different colours, so let's check out the colours first. We have mainly yellow. Okay, and I'm going to just consult with the front of the box there. And on the box it's showing just yellow LEDs, which are the panel mount ones. They're flat. And they have here in the instructions very specific bending guide, because they have to match up with that front panel. Oh, it's really specific. So it's basically saying from the long leg, first bend the leads exactly like in the drawing, but they're showing the drawing, but you're not quite aware which is the anode and which is the cathode. I can only assume, because of the way the PCB is, you have the short leg forward, okay, no, long leg forward, so that means you'd be bending it that way. But before we do that, let's do a different thing, because there's a very simple one here, which is the reception LED. You can fit that one right away. So you put the short leg to to the flat part. As soon as it focuses, you see there? So you want to put the cathode, which is the short leg of your LED, into that part there, which is LD5, like that. So let's start with an easy one that doesn't involve any bending whatsoever. I'm still reluctant to work on the other LEDs, you know, until we get that front panel. So let me have a think about this. Because if it all goes wrong, it's not going to look nice at all. So I'm just getting the panel work ready. So that's the base. This is the front panel there. It's going to fit something like that. And that board would screw in like that, so you can see it like that. And we want the long leg forwards on this PCB, so that long leg forwards is going to go in like that. So you can see the kind of bend you're looking for. And it's also just looking at it, it depends how much you want it to protrude. I think they're basically suggesting that it's going to protrude slightly if you do their 7mm, so let's go for it. We notice that there's a lump. Come on, stop focusing. You'll notice there's a lump on the end of the PCB, of the LED, and that looks to be about 7mm to me. So I'm going to do that. We're going to test one, and then we're going to bend the other one ever so slightly behind that. So it's looking something like that. If we zoom out, you can see from their picture, which isn't to scale, but it's something like that. So let's try it. We'll just try the one. And it's got a measurement on it though. You could see that they say it should be 11mm. So the one above the switch should be 11mm above the base of the switch. So whew, it's a lot to take in. And that to me seems to be more or less about 1mm above the switch. And I know it's difficult for you guys at home to see. I'm just going to tack it. Let me worry about it. Let me see if it gets it fitted. And if it's not right, you'll know. And if it is right, just copy it. So that's what I've got so far. That LED is just a bit askew. Yeah, I could have given it a bit more meat. So like, I think it should stick a bit higher. So you can see from my front panel here, when it focuses, the LED, it may never focus. The LED, you can bend it up to meet it, but it would like, so it won't focus. It would like to meet it, but it needs to be up a tiny bit. So let me just adjust that. Then I can show you where we settled. So I've got a little bit of play on here. You could do the same, of course, when you're doing it as well. Don't cut them too short. And if you wanted to be super sure about it, you could always remove the LED once you've got it just right and use it to measure against. So have a look there now. You can see there's a much bigger gap. I'll test that one. Much better. Perfect. I mean, I suspect once you fit this all together, you're probably going to want to put your hot snot on to make sure all that stays in place. But again, camera hates focusing on that, but it's flush. It's basically flat and flush in line with that. So I'll show you now the final permutation of where we got to with it. If you can get your one like that but more horizontal, you can see where it wants to end up. The LEDs are in. The LEDs are in. Okay. Watch the position of the notch, apparently. So we have two ICs. A pre-programmed pick goes into IC1, which is there. It's a 12C, so it's a one-shot deal. You could probably replace it if you want to make your own. And IC2, which is an LM285P, which is this one. We're going to pop that in there. Like that. And I've done that one wrong. Let's get the pick in there. The pick's in right. I'm just concerned. I should zoom in to show you why. And he's bent the legs. So just be careful. So you see on the holder there in IC2, there's some chips have notches in them, like this pick chip, and that matches the picture, and others don't, like this one. I wasn't paying attention. If you don't have a notch in it, that shiny dot is the end where the notch would normally be. So feel free to align that instead, and that's it. That's this guy, and the instructions are saying put it into the enclosure and do it all properly, but we're not going to do that because we're not finished with so many things. But I think it's a good point to test it, and it's 12 volts DC it's saying here, so I'm going to put my bench power supply on up to 12 volts, and I'm going to limit our current to 300 milliamps. I'm going to plug that in. Center positive, yes. Right, power on. Whoa! The motor's going. And it's still going. And it's still going. And it's still going. Okay. That was okay, but I'm just looking at the instructions here. So it's talking about doing the coil adjustment and testing. Right, so before we do adjustment and testing and get into it to do it properly, what I'm going to do is I'm just going to show you what happens when we power it up, because I feel I don't want to do any adjustment till we got the remote control working, because that doesn't make sense otherwise. Right, ready, go. Oh! What's gone with our thing? Right, so that didn't spin round that time, so maybe I've knackered it, so I'll have to test that. But listen, when I'm clicking the button, I know you can't see it potentially, it's a bit bright. So that's definitely our relay going. And we probably could try our reception thing using the other remote control I've got, but I'm not going to do that right now. I am slightly worried though about this motor. You saw it wasn't chooching around that time. You can hear it going. Oh yeah, okay, cool. It's fine. I think there's like a gravity thing going on there. Yeah, let's not worry about that. There's some sort of slipping clutch. We'll figure out how that works when we mount it all in. Right, so there you go. I think we are done with part one. And I think that's looking pretty awesome. Part two will be everything else that needs doing, and we'll get it going. Thanks for watching.